discussion on potential energy. So what is potential energy? It is the energy stored in the charged particle due to work done on it. So let us assume two positive charges Q1 and Q2. Okay, so force between the two positive charges, between the two like charges will be repulsive in nature. Okay, so Q1 and Q2 we have a repulsive force. Okay, so Q1 will repel Q2 and Q2 will repel Q1. Now we are applying some external force. Okay, for example, apply external force to Q2 so that you are bringing Q2 to a point P. Okay, so now we are doing this work. Okay, by applying external force, we are doing the work against the electric field. What is the nature? Repulsive force is the nature between two like charges. But when you do a work against the nature of this force, then some amount of energy will be stored in the Q2. Okay, that energy stored in the Q2, you call it as potential energy. Okay, so you're doing the work against the electric field and that work done will be stored as an energy in the charge. Okay, so Q2 applying external force to Q2 and we are trying to move Q2 towards P. Okay, but Q1 and Q2 will be repulsive in nature, but when you move against the repulsive force, now the work done on this Q2 to bring it towards the P will be stored as an energy. Okay, so the Q2 will have a high potential energy. So Q2 gains high potential energy. Okay, because we are doing it against the nature. So high gains high potential energies. When we gain a high potential energy, when we do a work against, okay, when you do a work against the field, okay, against the field, then that work will be stored as an energy Q2. Okay, now we'll see the formula. Potential energy U is denoted by the letter U. P is denoted by the letter, potential energy is denoted by the letter U is equal to K into product of two charges divided by the distance between them. Okay, so K, you know, Boltzmann, sorry, it is 9 into 10 to the power of 9 Coulomb's constant. Okay, this is the first. So what is the unit for potential energy? Unit will be joules. Okay, and it is a scalar quantity. Okay. So first question is, if distance between two like charges is increased, then potential energy will increase or decrease. So Q1 and Q2 are like charges. Now what you're doing is increase. Now we are increasing the distance. Now suppose you are bringing Q2 to some distance R. Okay, so now we are increasing the location of Q2 to R. So by doing this, what happens to the potential energy? So between Q1 and Q2 we have a repulsive force. Now again you are increasing the Q2 to some other location. Okay, assume that you are moving that Q2 to some other location from this point. Okay, now what happens? The repulsive force will further, it will increase only. Okay, now we are doing the action in favor of the electric field. We are doing the work in the favor of the field. Okay, now we are not doing anything against the field. When we are doing the work in the favor of the field, then the potential energy will decrease. So potential energy of Q2 will decrease. Okay, imagine applying some force. We are moving the Q2 to some other location. So we are increasing the distance. If we increase the distance, then we are doing the work in the field direction. So potential energy will decrease. So answer is decrease. Okay. Now if the distance between two unlike charges, consider Q1 and minus Q2. Okay, unlike charges, one positive and one negative, is increased. Okay, then the potential energy will increase or decrease. So what happens to this? So Q1 and minus Q2. So here what is the force between this positive and negative? You have an attractive force. Both gets attracted. Now what you are doing? You are increasing the distance. Okay. So now suppose we are moving this to some other location, okay, in the axis. So now what happens? Now we are doing the work against, because Q2 will and Q1 will attract each other. Now you are moving it away. So now we are doing against the electric field, okay, against the attractive force. So when you do a work against a attractive force, or when you do a work against the field, then the potential energy will increase. So here the answer will be increase. Okay, next. If two charges in a system, okay, is negative, then the potential energy of the system will be, okay. So two charges in a system, let it be Q1, another one charge is minus Q2. Okay, let two charges be Q1 and minus Q2. Then the potential energy, so Q is equal to K into Q1 of minus Q2 by R. Okay, so you get a negative value, minus K into Q1 Q2 by R. Okay, so the potential energy of the system will be, if two charges system is negative, okay, two charges are negative, okay, so this is also minus Q1. Two charges are negative, then minus minus becomes plus. So the potential energy of the system will be positive. Okay, so U is positive, because they said two charges in system is negative. Okay, so minus, let it be minus Q1 and minus Q. Assume that two charges to be minus Q1 and minus Q2. Substitute in the formula. So minus minus becomes plus. So the potential energy is positive. Will increase. Now a particle with a charge of, okay, 5 millicoulomb. Okay, charge is 5 into 10 to the power of minus 3 coulomb. Okay, let it be Q1, and Q2 is at a distance of 0.5 meter from a charge of 6 millicoulomb. 6 into 10 to the power of minus 3 coulomb. So distance between them is 0.5 meter. Okay, these are the given quantities. Now you have to find the potential energy. So U is equal to K into Q1 Q2 divided by R. So K is equal to 9 into 10 to the power of 9 into 5 into 10 to the power of minus 3 Q1, and Q2 is 6 into 10 to the power of minus 3 the whole divided by, okay, 0.5 meter. Okay, so powers become 10 to the power of 9 into 10 to the power of minus 6. So when you multiply this, you'll get 270 into 10 to the power of 9 into 10 to the power of minus 6 divided by 0.5. So you get the answer to be 540 into 10 to the power of 9 into 10 to the power of minus 6. We'll get 10 to the power of 3 joules. U is equal to, this is the answer. Just substitute in the formula. Now C and D are the 2 points in an electric field. If the work done in carrying a 5 coulomb of electric charge from C to D is 20 joules, then the potential difference between C and D. Okay, work done is equal to 20 joules and charge value is equal to 5 coulomb. Now you have to find out what is the potential difference between VC and minus VD. You have to find it out. Okay, so the formula is W work done will be equal to charge Q multiplied with the potential difference VC minus VD. So Q value is 5. We have to find out VC minus VD, and W value is 20. So therefore we'll get VC minus VD is equal to 20 divided by 5 is 4 volt. So answer is 4 volt. So the option is D. Next is find the work done, okay, to move a minus 1 coulomb charge. This is the minus 1 coulomb charge from the origin, okay, to infinity. You have to move this to some infinity point. Okay. If the separation between 2 coulomb charges, okay, separation between 2 coulomb charges, total separation is 6 meter. Okay, so from center, this origin, so you'll get 3 meter to the left and 3 meter to the right. Now what is the total work done? We have to calculate. Okay, so initial potential, okay, initial energy of the system, the entire system, what is the initial energy of the entire system, plus some work will be done to move this minus 1 coulomb charge to infinity, will get the final energy of the system. Okay, initial energy, what is the initial energy, potential energy of the system, then what is the amount of work done in moving minus 1 coulomb charge to infinity, you will get the, that will give you the final work done. Okay, that will be final energy. Okay, so what is U initial? So let it be 1. So what is U initial of the system? Okay, energy of the entire system. So will be the energy between this 2 coulomb charge and this minus 1 coulomb charge, and the energy between this 2 coulomb and this minus 1 coulomb, and the energy between both the 2 coulombs. Okay, so you'll get the energy between, okay, this 2 and minus 1 coulomb charge, let it be A, B, C. Okay, so we can write it as energy between U, A and B plus the energy between B and C plus the energy between A and C. Okay, 2 to minus 1, then minus 1 to 2, then between A and B. Okay, this is the total initial energy of the system. Okay, so next is what is the final energy. We can write the formula of expression for final energy. So final energy is here, by doing the work we are moving the minus 1 coulomb to infinity. So we'll be left with 2 coulomb and 2 coulomb, as minus 1 coulomb is moved away. So only this will be remaining. Okay, so will be the energy between this A and C. Okay, so let it be 2 and let it be 3. Okay, now you substitute this 2 and 3 in 1. So U initial is UAB plus substitute 2 and 3 in 1. So UAB plus UBC plus UAC plus W, okay, will be equal to U final values UAC. Okay, now make use of potential energy formula. Okay, so K into, so what is the charge between A and B? You have K. Okay, we know the formula for potential is K into 2 charges divided by R, right? So K into what is Q1 is 2. Between A and B it is 2. B is minus 1 and the distances R is 3. Plus between B and C it is K into 2 into minus 1 divided by 3. Okay, between A to C we can cancel both the things, right? UAC and UAC can cancel out, so plus W will be equal to 0. Okay, this, if you cancel this, UAC minus UAC will become 1 minus 1, this UAC will get 0 here. Then we'll get minus 2k by 3, okay, minus 2k by 3, okay, plus W is equal to 0. Okay, so 3 will get minus 4k plus W is equal to 0. Just to bring this to here, then we'll get 4k by 3. Okay, so what is the value of k? We know that value of k is equal to, substitute k is equal to 9 into 10 to the power of 9. So therefore W will be equal to 4 into 9 into 10 to the power of 9 by, okay, then what will be the answer? We can cancel this, so we'll get 4 into 3, 12 into 10 to the power of 9 joules. So initial of energy of system, then the work done will give you the final energy of the system. Now the 3 positive charges, okay, are placed at the vertices of the triangle, this QQ. If a negative charge is placed at the centroid, then the potential energy. So when you place a negative energy, negative charge, then what happens to the potential energy? Okay, so at any point, suppose we find out the between the center point UA, let it be O, center point the charges UAO, then we'll get K into Q minus Q by some distance R. Okay, so you get an answer of negative value. So the potential energy gets UAO gets decreased. So from any corner to center, you get the potential energy of the system to be decreased. Okay, so it get decreased. So the option is B. Okay. Now if an electron accelerates in the potential difference of 100 volt, so potential difference is, okay, potential difference is 100 volt, then its kinetic energy will be, okay, so work done will be equal to change in the potential energy will be equal to charge multiplied with potential difference. Okay, so what is the charge? Charge of an electron is equal to 1.6 into 10 to the power of minus 19 coulomb. So you'll get 1.6 into 10 to the power of minus 19 into potential difference is 100. Okay, so you'll get 1.6 into 10 to the power of 19, you'll get it to be 10 to the power of minus 17, okay, joule. Okay, so this work done in accelerating, okay, this potential energy while accelerating will get converted into kinetic energy. Okay, so this potential energy accelerates will get kinetic, will be in the form of a kinetic energy. So the kinetic energy value will be equal to 1.6 into 10 to the power of minus 17 joules. Okay, so option A. So an electric dipole moment P, okay, is placed normal to the lines of force of electric intensity E. Then the work done in deflecting it through an angle of 180 degrees. So you have a dipole, okay, electric dipole moment. Okay, so the work done will be equal to integration of P sin theta d theta. Okay, so between the limits from you have to find it from 180 degrees, so from 0 to 180. Okay, so when you integrate this, we'll get PE minus cos theta. Okay, when you integrate this, we'll get minus cos theta after integrating. So it will be minus cos theta 0 to 180 after integrating. So which will be equal to minus PE cos theta value of 0 to 180. So what is cos 180? Cos 180 value is 180 degree is equal to minus 1 and cos 0 is equal to 1. Okay, so we'll get PE into 1 plus 1. So and 2 PE. So work done will be equal to 2 PE. Okay, so minus of 180 is minus 1. So it got plus 1. So again minus of minus cos 0 will become plus 1. Okay, so option is B. Okay, next is an electric field of 1000 volt per meter is applied to an electric dipole at an angle of 60 degree. Okay, so electric field strength is given as 1000 volt per meter is applied to an angle of theta is equal to 60 degree. The value of electric dipole moment is P is equal to 10 power minus 20 coulometer. Okay, this coulometer. What is the potential energy of the dipole? So formula is U is equal to minus P cos theta is the formula for potential energy of a dipole system. Okay, so P value is 10 to the power of minus 20 into V value is 1000. Okay, cos 60 is cos 60 degree is equal to 1 by 2. 1 by 2. Okay, so we'll get minus of 20, we'll get it as 17, right? Okay, so 10 to the power of minus 17 into half will be 0.5. So the answer will be equal to minus of 0.5 into 10 to the power of minus 17 joules, or you can adjust the powers, then you can get it as minus of 5 into 10 to the power of minus 18 joules. Okay, just multiply by 10, multiply divide by 10, then we will get 5 into minus 5 of 10 to the power of minus 18 joule is the energy for the dipole. So U minus P cos theta is a formula for potential energy of a dipole. Okay, next is if a point charge moves round in a circle about a charge Q, okay, let Q, then the work done by the charges. So we know work done is equal to force into the distance moved, that is displacement, right? Force into the distance moved. So work is equal to force into, so some charge Q is there. Okay, some charge Q is there and you are applying. So work done on it is force acting on it, okay, as well as the displacement of that charge. Okay, so have an angle of 90 degree between these two. So W is equal to F into S. It's a dot product. Okay, W is equal to F into S, dot product. So dot product of the vector, we have it as cos theta. So W is equal to Fs cos theta. So theta here is 90 degree. So cos 90 is equal to 0. Therefore W will be equal to 0. Okay, option D. This is the force vector and x vectors, taking the dot product of this vector. Okay, electric potential of a 2 nano coulomb. So electric potential of a charge is 2 nanocoulomb is 10 to the power of minus 9 coulomb. Nano is 10 to the power of minus. At a point is 4 volts. So potential is equal to 4 volt. Then its potential energy. You have to find out what could be the potential energy. Okay. So V is equal to, we have the relation potential is equal to potential energy divided per potential is equal to energy done per unit charge. Okay. So therefore V is 4, U we have to find out, and Q is 2 into 10 to the power of minus 9. So 4 to the, therefore U is equal to 8 into 10 to the power of minus 9 joules. Okay, this is the answer. Okay. Next is an electric dipole when placed in a uniform electric field will have minimum potential energy if the angle between dipole moment and the electric field is. Okay, so we know the formula U is equal to minus P cos theta. Okay, so first they are given 90 degree, 180 degree when we have the minimum energy. Okay, so when you substitute 90 degree, we'll get U becomes 90 degree. When theta is equal to 90 degree, then U becomes what? 0. Cos 90 is 0. When theta is equal to 180 degree, then we'll get U as some negative value will be there. Okay, negative plus negative becomes positive. Cos 180 is minus 1, so minus minus becomes some positive value will get. When theta is equal to 60 degree, we'll get U value some by 2. Okay, when theta is equal to 0 degree, that time we'll get U as 0. Okay. We'll get U values to be 0. Okay. So U minimum will get 0 value when you'll get when theta is 0 degree. Okay, so when theta is equal to 0 degree, we'll get, sorry, cos 0 is 1, so you'll get cos 0 is 1, so U will be equal to minus PE. So you'll get minus PE into cos 0 is 1, sorry. So we'll get U minimum is equal to minus PE, negative value. Okay, so answer is 0 degree. Okay, hope you understand potential energy. Thank you students, kindly subscribe, like and share with your friends. Thank you.